Inequalities. The good news about solving inequalities is you already know how to do it. It's very, very similar to what we did in solving two-step equations. So let's look at this two-step equation and let's solve it. The first thing, if I look at my order of operations, the x is being multiplied by -2, and then we add 3. So if I'm undoing that and I'm working backwards, the first thing I have to do is subtract 3 from both sides. So now I get 2x is equal to 8, because that's 11 minus 3. And then I need to undo the multiplication, so I divide by -2. And I get that x equals -4. So all of those steps are going to be the same when this problem becomes an inequality. So notice that it's the same thing, but instead of an equal sign, now I have a less than or equal to. So we're going to solve it the same way, right? First step, subtract 3. Then I bring my -2x down. I bring my inequality symbol down, and 11 minus 3 is 8, right? So so far, it's exactly the same process. All right, here's the one difference. Notice that I did say there's one difference. The one difference is if you multiply or divide on both sides by a negative, the inequality symbol has to flip. Okay, that's the only difference. Other than that, this is exactly like solving equations. So when I do -2 divided by -2, I get 1, right? That's still x. But because I divided by a negative on both sides, I have to flip the inequality. 8 divided by -2 is still -4. So this would be my answer. And it's important when you're solving an inequality and you give a solution at the end, not to just say the number. Because for an inequality, the solution is a whole lot of numbers. So in this case, any number that is either equal to -4 or smaller, or greater, right? Because this is x is greater than or equal to -4, will be a solution. So that means, 0 is greater than -4. It's in the solution. 5 is greater than -4. It's in the solution. -2 is greater than -4. It's in the solution. So the solution contains all of the numbers that are equal to or greater than, in this case. So the way that you would show this in a number line graph is I'm going to put 0 on my number line graph, and then I'm also going to put -4. And the solution is all of the numbers that are either equal to -4, so I'm going to shade in a dot on -4, or bigger. So the numbers that are bigger are all of these numbers to the right. So I'm going to shade my number line and just make it like thicker. And then I'm going to put an arrow to show that that solution would continue. So starting with -4, all of the numbers that are bigger would be included in this solution. And when I say included in the solution, I mean that if you take any number from the shaded part of the number line and you plug it in right here for x, it's going to come out to be less than or equal to 11, right? It's going to make it true. Okay? All right, so now let's take a look at what we do when we have inequalities and word problems. And you actually use this a lot more than you probably even think about. So you're at the mall, sale on video games, yay. The games are on sale for $9.99 each. I guess they're games that are a little bit older, maybe. And you need to buy a new controller, which is on sale for $14.99. How many games can you buy if you only have $50? Okay, so what we're going to do is first we're going to set this up as an inequality. And the inequality is going to be the cost. So here's what I'm buying. I am buying a controller, right? So that's going to be $14.99. Plus, I'm going to spend $9.99 on each video game, right? So I'm going to put G for games. $9.99 times the number of games. And when I add the money I spend on games and the money I spend on the controller, I cannot go over $50 because I don't have more than $50, right? So this amount that I spend has to be less than or equal to $50. And of course, we're not talking about tax here, right? Because once you include tax, then actually I need to be under $50. Okay, so how are we going to solve this? Well, if I look at the G is being multiplied by 9.99, and then we're adding on the $14.99. So I'm going to undo the $14.99 first. Oops, that should be a 4. And I'm going to use my calculator for this. So I have $9.99 G is less than or equal to, and so on my calculator, I'm doing 50 minus $14.99, and I get 35.01. Okay, so the last step to undo this multiplication is to divide by $9.99. And I'm going to move my problem over here because I have a little more room. So $9.99 divided by itself leaves me with just G. And then I leave my inequality symbol. And then I'm going to do this on the calculator too. I'm going to do 3501 divided by 9.99. And I got 3.5. Okay. So let's talk about what this means. G is less than or equal to 3.5. Is it possible? And I rounded, by the way. It came out to be 3.5045, so it repeats. But, I mean, is it possible to buy 3.5 games? No, I can't buy a half a game, right? So this means that the maximum amount of games I could buy would be 3, right? I could only buy 3 games. If I were to graph this, now I'm going to show you 2 different ways to graph this. If it weren't a real world problem, if this was just an algebraic inequality that I solved, the way that I would graph this would be different. So I'm going to show you that way first. If I want to graph G is less than or equal to 3.5, I have to make sure 3.5 is on my number line. Because it's equal to, that means I have to shade 3.5. And then because it's less than, I would have to shade all of the numbers that are less than 3.5. And then I would put an arrow to show that my shading continues in that direction. Right? That's if this was not a real world situation. But it is. So since this is a real world situation and I know that I can't have decimal, fractional numbers of video games, I would do this a little differently. Here's my number line. I also can't buy negative games, right? So if G is less than 3.5, that means the most I could buy would be 3.5 games. But obviously I can't do that. So the most I could buy would be 3. But if I wanted to graph the whole solution set, then I could also buy 2 games. Or I could buy 1 game. Or I could buy no games. right? So those would be the possible solutions for this real world situation. I could buy 0 games, 1 game, 2 games, or 3 games. But I couldn't go up to 4 because my solution is that G has to be less than or equal to 3.5. Okay, let's take a look at another situation. You got $300 for your birthday. Lucky you. There's a show that you want to go see with some of your friends. You're going to use the money to buy tickets for some friends and a shirt from the show. If the tickets cost $48 each and the shirt is $20, how many friends can you invite? So again, we're going to write an inequality for the amount of money that we're going to spend. So we're going to buy tickets that are $48 each and a shirt that's $20. So I'm going to buy tickets for friends, right? So I'm going to spend $48 per ticket. I'm going to use X because I don't like to use T because it looks too much like an addition symbol. So $48 times the number of tickets, plus I'm also going to spend $20 on a shirt, and I need that to be less than or equal to 300. It's okay if I spend less than 300, but I can't spend any more than that. So it has to be less than or equal to 300. So using order of operations, if I look at where my X is, the first thing order of operations would tell me to do is multiply by 48 and then add 20. So I'm going backwards when I'm solving. So that means I have to subtract 20, right? Subtract 20. And then I get 48x is less than or equal to 280. All right. And now I have to undo the multiplying by 48. So I'm going to divide by 48. And I'm going to do that on my calculator. 280 divided by 48. So x is less than or equal to 5.83 repeating. So again, obviously, can't have 5.83 repeating number of friends, right? So the number of friends, the maximum number of friends that I can invite would be 5, right? Because I have to stay less than or equal to 5.83 repeating. Now I'm going to show you 2 ways to graph this. If this were just an algebraic inequality, no word problem, right? No real world context, then the way that I would graph this would be to put 5.83 repeating on my number line, put a dot on 5.83 because it could be equal to that number, and then shade all the numbers that are less than, right? So that would be down here. I would be shading. That's if this was just an inequality, no real world situation. I would shade all of the numbers on the number line that are less than or equal to, right? The arrow is the less than, the equal to is the dot, 5.83 repeating. But this is a real world situation. So since it's a real world situation, my graph of solution points would look a little different. If I have to keep my number of friends under 5.83, that means, oops, hold on, let me go back. Let me erase that. All right, that means that all of these numbers would be included in my solution. Now I'm putting 6 on here, but I'm not going to put a dot on 6, right? Because I don't have enough money to invite a 6th person. So I could buy the shirt, and then I could either have no friends, 1 friend, 2 friends, 3 friends, 4 friends, or 5 friends. But if I was asked for the maximum number of friends that I could invite, the answer would be 5.